to look at the world through my daughter's eyes, she's 8 now. She reads, she writes, she does arithmetic, she does some art. She actually searches for stuff. I think in her lifetime, we'll see dramatic impact on all of those basic skills. Question, if it's okay by you, I'll kind of give you a 2-minute history of the field, if you will, of how we came to this point. Because it's very interesting for me, because I've kind of seen the journey.
All right. So, hello and welcome everyone to who's ever listening to this particular podcast. Today we have with us Dr. Anupam Datta. He's the co-founder and president of TruEra, and prior to that, he was a professor at Carnegie Mellon University for around 15 years. TruEra provides AI solutions that help enterprises use machine learning and various tools employed by machine learning and AI, improve and monitor the performance and quality of these models, and also build trust in these models. His research and other efforts are focused on privacy, fairness, and building trustworthy machine learning models. He also holds a PhD in computer science from Stanford University and a bachelor's degree in the same from IIT Kharagpur in India. So thanks a lot for being here, Dr. Datta. It's really nice to have you.
Thank you, Jay. It's a pleasure to be on your podcast. I'm looking forward to the conversation.
So for people who might not know who you are, can you tell us a bit about your background and your research interests as a professor and also your current position at TruEra?
Yes, certainly. So I grew up in India. I studied computer science at IIT Kharagpur, and then from there went to Stanford to get my PhD. At that time, I was working in security and cryptography. And after the PhD, when I was starting my postdoc, I wanted to work in a similar area, but with a closer connection to immediate social impact. So I started working in privacy, which is a neighboring area. And then when I went to CMU in 2007 to join the faculty there, I continued the research arc in privacy, but also realized fairly quickly that the intersection with machine learning is where a lot of the exciting open problems were. And so that was kind of a transition. And as we started digging deeper into machine learning and its impact on the world, related to privacy in a very natural adjacent area was fairness. And so I started going deeper into fairness. And studying fairness also raised this question of what is causing the machine learning model to sometimes behave unfairly. And that in turn led to a body of work around explainability and debugging and root cause analysis of machine learning models, which, while it's very directly applicable to fairness, is also applicable to a lot of other quality and trustworthiness attributes of machine learning models. It applies equally to questions of why might a model be performing not as well in production as it was when you trained and tested it. It applies to questions of drift in machine learning models. You have deployed a model into production, and then the world has changed, or the data distribution has changed. And when that happens, it's useful to understand why, and then readjust your models with that kind of knowledge in the background. So that was kind of the arc of my research journey, going from security into privacy, into machine learning and fairness, and then explainability. And then ultimately at one point realizing that as machine learning is getting adopted at a very wide scale, it's extremely crucial to ensure that the quality of these models and their trustworthiness is well understood and maintained as models are being developed and as they move into production. And that led to the founding of TruEra, the core technology foundation here being around measurements of model quality and associated data quality, and tooling to support root cause analysis and debugging of models and maintaining their quality over time in a way that they both deliver business value and do so in a way that's responsible and does not cause harm to marginalized groups.
I see. So I think you mentioned a lot of keywords that are very intriguing. So you said like you had the trajectory from security all the way till explainability, but there are also a lot of terms like I think robustness, I would say trustworthiness, reliability, all these terms. Like I feel these are normally terms used interchangeably. Like, do you see a major overlap on these terms? Like, what do we exactly mean in a technical way? If I'm building an AI model, what exactly technicalities I need to add to that system so that someone can say this is a trustworthy AI system? Like, have you researched more on this particular aspect?
Yeah, I think of trustworthiness of AI or trustworthy AI as kind of an umbrella term that includes a number of specific kinds of attributes that you may want of an AI model. The one attribute that people often focus on quite a bit when they're building machine learning models is around model performance or accuracy, right? So usually when you're training a machine learning model, you're trying to design the most accurate model that you can. And that's what gets tested. And that's certainly a very important pillar of trustworthiness. You want your models to be accurate. If it's a model that is making decisions based on images on who has cancer and who doesn't, the accuracy of the model is of paramount importance. So that's first. Now, once you go from beyond that, you want to also look at a number of other attributes that will help track whether the model is going to generalize well to unseen data. So even when people are measuring accuracy, they will do it on training data on which the model is trained, but also evaluate it on new data or testing data which the model had not seen before. But then there are other elements. You mentioned robustness, for example. Robustness captures the idea that small changes in the input should not change the model's output too much, right? So if it's an image analysis machine learning model, you take a picture of Orlando Bloom, say, you make some small changes in pixels, and if it suddenly looks like Drew Barrymore to the machine learning model, then that's not a robust model. Or you take a stop sign and you put a few stickers on it, and now suddenly it looks like a tree to the machine learning model that might be running in a self-driving car, then that can have very significant impact. So robustness is important also in order to ensure that models generalize well. Another kind of dimension is around stability or drift. You train machine learning models at one period of time. Now you push them into production. Once the model is in production and time has passed, it could be that the world has changed dramatically. And some of the relationships that the model had learned from the training data no longer hold true. That would be an example of what's called concept drift in machine learning. And that happened a lot during COVID times. Many of these supply chain models, for example, that are used to predict how much consumers will buy of various types of items went completely out of whack because suddenly there was a huge demand for hand sanitizers and other material used to sanitize, which isn't something that was true in the world before the early days of COVID. And that's just one example. Housing market can change. We saw the Zillow example where Zillow was using machine learning to estimate prices of houses. And then when the housing market cooled down suddenly in certain geographies, the machine learning models weren't keeping up with the changes in the world. They overestimated the prices, and Zillow lost close to $500 million. So those are some other dimensions going beyond accuracy, but other indicators which might have impact on model performance, like the robustness of the model, drift in the model. Fairness is another dimension, which we touched on briefly. in various kinds of use cases, you want your machine learning models to be fair, to not treat certain groups in ways that might harm them. We have seen that in studies of facial recognition systems, for example, which were shown to work much better for white males than for African-American females, or recidivism prediction systems, which were studied some time back, and there were indications that they might be biased against African-Americans. Credit decisioning systems, fraud decisioning systems, and so on. There's lots of examples of where machine learning is being used in impactful areas where fairness is extremely important. And then finally, you touched also on explainability or interpretability. So that's another area where of trustworthiness, making sure that we have a good sense of what's driving model predictions. Is it based on reasonable factors that will result in correct decisions, or has the model just picked up on spurious correlations in the training data, and therefore it'll continue to impact the world in ways that are not great. So those are some of the elements that constitute go under the umbrella of trustworthy AI, or AI quality, which is another term that we use for this space. Performance of models, drift, fairness, explainability, and robustness.
I see. And my other question would be tied to this. So I think I'll tie to these two questions. So one is realizing where these models are failing, like as in the things that you just mentioned, when they are deployed in the real world, like what are kind of data distribution drifts versus the data that was used to train the model that can, like if you're using it on a completely different data set, it might produce some very spurious predictions. And the second thing is like trying to fix them. My first question is, have you come across any methods? Like, do you think there should be a validation framework that should be deployed in real world practice that says, if you are using an AI system, you should have this kind of validation framework to make sure it is ready to be deployed in the real world or not? And my second question would be does these things tie to the real world scenario of what we have for, let's say, big models like ChatGPT, Dolly, because these are fairly big models. So it's very hard to have metric, right? Like for smaller systems, I know what they really look like and how it was trained, like everything is published open source, versus the other things like these are closed box models. We don't know, it gives great results. Like you said, the accuracy has been reached at its very big point. So yeah, to summarize, like I have two questions, as in what should be our focus, as in the training model itself, the conservative technique that we used to have, or should it be framework that post-analyzes it? And what happens when we have models like ChatGPT?
Yeah. So maybe I can answer them in stages. So I think for more traditional machine learning models and deep learning models, it's absolutely very valuable to have a framework and tooling to validate the models, both before you move them into production and then monitor them on an ongoing basis to ensure that the models are still of a high quality and are trustworthy. Along the dimensions that I mentioned earlier, you want to keep track of how they're doing with respect to accuracy and performance metrics, drift, fairness, and so on. And there is already a lot of work in this space. There are certain fields in which there are standards. So for example, in financial services and banking, model risk management is an entire function whose focus is on validation of models, both before they move into production and then on an ongoing basis once they are in production. Historically, that function has focused on more traditional models like logistic models and generalized linear models and so on. And then over time, as the adoption of machine learning has grown, that function has also built up capabilities for evaluating more advanced machine learning models like tree models and XGBoost models and deep learning models for NLP and so on. And that's one vertical, but the same kind of principle and tooling and framework is actually valuable for pretty much any team that is building and deploying machine learning models. And in some ways, like this is one of the biggest areas where there has been considerable advances in research and tooling, and now the industry is starting to starting to see a lot of uptake in the industry as well. So in my view, every machine learning team that's building and deploying models needs to have a framework and tooling to support validation and monitoring and ongoing management, if you will, of the quality and trustworthiness of their models. Now, turning to your other question about large language models like ChatGPT, which are taking the world by storm right now, what do we do there? So maybe I think, well, before I answer the validation question, if it's okay by you, I'll kind of give you your viewers a bit of a 2-minute history of the field, if you will, of how we came to this point. Because it's very interesting for me, because I've kind of seen the journey. Around 2013, 2014 is when deep learning for natural language processing started to really take over. Before that, it was more traditional statistical methods based on n-grams and analysis of frequencies of n-grams, which were the dominant method. And before that, it was much more linguistic structure and syntactic methods and logical methods, right? So we started going from a more logic-based AI world towards statistical methods, but simpler ones over n-grams. And then around the 2013, 2014 timeframe is when deep learning models for NLP started to take off, right after the computer vision, deep learning for computer vision, which was with a couple of years before that. So in those early days, well, not that early, but about a decade ago now, recurrent neural networks and LSTM models and GRU models and bidirectional LSTMs, those kinds of models were the dominant models that helped with a number of these language tasks. And in particular, if you think about language models, what is a language model doing? It takes as input a sequence of text and it predicts the next word, right? So if you give it an input like the most amazing soccer player in the world is, and then it might spit out Lionel Messi or someone else, depending on which team you root for. Now, if you just apply the language model repeatedly, you can get a sequence of text out of that model, right? So that at some high level is how generative language models work. You give it a sequence of text, which could be a question, and then out comes another sequence of text, which is the answer. For people who have been playing around with ChatGPT recently, this will be a familiar experience. Now, with these models, the LSTM models and GRUs and bidirectional LSTMs and so on, they were doing better than the n-gram-based statistical models. But one problem they had was they couldn't remember very long sequences, right? So if you give it a long sequence of input text and then expect an output, it didn't do very well. So there were some problems with how the gradients worked and so on. Then came transformer models around 2017, 2018, when that paper, Attention is All You Need, came out from Google, BERT models. And that, at that time, was a very interesting paper. But over the last few years, we have seen how big the impact of it has been. There have been tens of millions of downloads. If you look at Hugging Face, for example, and lots of applications that were built off of BERT models as a common core or foundation model. And one of the nice things about those models is that you have the core model, but then you can adapt it to specific tasks. So you could have question answering or sentiment analysis or a bunch of other tasks that you build off of it. So that was a big step forward in this arc. Now, if you fast forward from that BERT model moment, and there were a number of other variants in that neighborhood, there's DistillBERT and Roberta and so on, the path to ChatGPT had a few other innovations. One was just the way tokenization works. So in the way language models work is you get a sequence of text, then each word gets broken down into some tokens. So if you say stemming, then that might be broken down into stem and ing as the tokens. And then those get converted into something called embeddings, which are a way to encode tokens in a more compact representation. And then those get processed by the model, right? So how you do the encoding can have a lot of impact on the compactness of the embedding, and its density has impact on how big the token space is that you can efficiently represent and get trained on. And so there were some interesting innovations in that space with byte pair encodings. And then there was another big innovation around reinforcement learning based on human feedback, which meant that when you're training these models, with the byte pair encoding advancement and just the scale, we went all the way up to GPT-3. GPT-3 is like a 175 billion parameter model, which was trained on a very, very broad swath of text from the internet. And it could do amazing language generation. But a 175 billion parameter model is very, very expensive to train. Its inference is extremely expensive as well. It still found lots of useful applications, but the thought was one could do better. And then the one other key innovation that enabled that jump from GPT-3 to ChatGPT was leveraging something called reinforcement learning with human feedback. And that meant that when you are training the models, in addition to the unsupervised training on large swaths of data to get the language model, you also did a small collection of inputs on which humans provided feedback, where they were not only saying that this is the right answer to this question, but given a choice of options, they were kind of ranking them, saying this is better than that. And that helps with learning something called a reward function. And then that can then help the model do a better job of picking among options. And with that advancement, we came to ChatGPT. ChatGPT is a much smaller model, closer to the 1 to 2 billion mark in terms of number of parameters, and closer in terms of number of parameters to BERT as well, which is in that same neighborhood. And yet it does a significantly better job in language generation and question answering than GPT-3. So that's kind of the arc of the journey from logic-based methods to statistical n-gram-based methods into deep learning with LSTMs and GRU models and bidirectional LSTMs. Then came transformer models, and then finally the current generation of GPT-like models. And the part of the reason I brought up this journey is that it's useful to have that framing in mind when you think about how should we go about validating or evaluating the models, which was your original question some time back. Now, there are a few things that I would highlight as crucial when you're thinking about validating these kinds of models. First is human in the loop validation or evaluation is extremely crucial. And it's in some ways, that is at the very core of how ChatGPT works, because the way it's trained to begin with reinforcement learning with human feedback, sets it up in that direction. So this is something we will expect will be the number one pillar for validation of large language models, having a very crucial element of human in the loop of validation. The second thing I would say is the large language model as you know, is a foundation model. But then what you do is you fine-tune that model to specific tasks, end tasks that you may want to actually solve. So that end task could be a sentiment analysis model. Let's say you want to start with something like a GPT-3 model or a ChatGPT model, and then you fine-tune it to assess sentiments in financial headlines, to do stock picking or portfolio picking or something like that. Then the evaluation needs to be tied to the metrics associated with that end task, right? And some of those metrics will be like the metrics we discussed before for accuracy of models and performance metrics and drift and robustness and so on. And some of them can be related to the business KPIs associated with the task, right? So if you're using this model to generate some stock picking advice, then you evaluate it based on how it's actually doing with its in terms of making you money. Or if you're using it to generate marketing content, which then you use to draw users, potential users to your company's website, what are the marketing metrics? How are they getting impacted by its work? So that's the second pillar. So the first is just having a very significant element of human in the loop in the part of evaluation. Second is the focus on the end task and the metrics around it, and go do a deep evaluation with respect to those metrics. The third thing I would say is, and this is where there's a lot of white space and an opportunity, is a lot of the emphasis has historically been on the accuracy metrics, but some of the trustworthiness evaluations here, looking at deeper analysis that looks at the metrics, but also looks at the root causes for why metrics might be going up and down. And that's another area with the scale of these models and sometimes the restricted APIs that you have to access them raise additional challenges that go beyond the traditional deep learning models. So for example, if you're looking at a model that's 100 times bigger than what you're used to, gradient-based explanations will have to scale them as well. If you're looking at restricted APIs, like with OpenAI, for example, you don't get access to the model objects, so you can't compute gradients. So you'll have to do other forms of analysis that might make use of the input-output behavior or the embeddings that you will have access to through the API. So those are some areas where there's some unique and distinctive both challenges and opportunities for deeper validation of these models. And I would say that your question is spot on. It's extremely important to do this validation right, both before these kinds of models get started, are starting to get used extensively in lots of very high stakes use cases, and the impact of these models is going to be very significant in the world. And that's something we can chat about as well.
Yeah, definitely. That is actually precisely my next question. But first of all, thanks a lot for that history. I think even though I knew the history of how these language models have evolved, but I think I really like understanding from a very deeper perspective. So thanks for that. And I think to summarize also what you said makes sense, as in these trustworthy or explainable systems have to be very application specific, meaning like it could be different from when these models are deployed in medical world versus judiciary world, or like you said, in stock market prediction. So it really depends on those KPIs. But yeah, it's actually precisely, you're right. Like my next question would be is, first of all, like the challenges that like, because there's a lot of positive sentiment versus also a negative sentiment when these models are deployed in the real world, right? Like ChatGPT, like if you see people, some of them are really scared, like, okay, it is really going to change the way how we search things. And there are lots of other theories being thrown around, versus a lot of people like us are also happy or very positive, as in like, this is something new or groundbreaking technology or research. So I want to know, like, as in, what do you think it is going to change the world? As in, like, is something like search or some other domain of the world is being impacted a lot that people will have to just adapt to it? And what do you think are its current challenges? Like something it still fails by a big margin that is being claimed for?
Yeah, that's a great question. Yeah, I would say that, like, if I were to do a sentiment analysis on myself, it would be cautiously optimistic. I do think that there's a lot of opportunity here for this class of technologies to be incredibly transformative in the world. At the same time, I do think that adoption needs to be carefully coupled with careful testing and validation and monitoring so that we stay on top of these models, making sure that they are delivering on their business value while also guarding against the harms that they could inflict at massive scale. If I were to get a bit more specific, like if I were to look at the world through my daughter's eyes, she's 8 now, and what are some of the activities that she does? She reads, she writes, she does arithmetic, she does some art, she actually searches for stuff in a restricted way to do small research projects for school on various topics. I think her life is going to, in her lifetime, we'll see dramatic impact on all of those basic skills. And she does a little bit of coding as well. So if you look at those activities, how we read and search for information, I think will change dramatically. And we are already seeing some of that with Bing's tie-up with OpenAI, and Google is pushing it as well. And then there are various startups also in this space. We will start getting more specific answers or detailed answers to questions as opposed to just a list of links. One thing that will be extremely important is not making stuff up. We know that some of these models have these limitations, that they will have hallucinations and they'll make stuff up because so attribution is important in that context, and some form of attribution people are working on, where if the model comes up with an answer, there's a list of links to sources that corroborate that answer. Getting that right is extremely important. It's not yet at that point where we have deep attribution all the way back to the actual reason why the model came up with that answer, but at least having this ability to check the model's work against other more authoritative sources would be quite valuable. Writing, I think writing will change quite dramatically. It can be an incredibly powerful writing assistant in certain areas like content creation. Getting to that point where these kinds of technologies are not replacing humans necessarily, but augmenting them in meaningful ways is starting to happen already. Well, what does that mean for my daughter? I think that is a very good question, right? The very nature of how you write and the creative activity can change when you have a writing assistant of this kind sitting next to you. So these are a few areas. I mean, art, we have already seen. You have in our previous conversations, we have talked about DALL-E and stable diffusion and these kinds of systems, and creative artists who have created lots of original work. Moving forward, how does that change? It can change quite dramatically, and there are already some startups. There's a former CMU student who has a company in this space looking at art and fashion design and things like that, leveraging generative AI. Coding, we have seen Microsoft's Copilot, right? It's there's a lot of common patterns in coding, and software developers will often cut and paste and reuse each other's work in order to move faster. The open source movement has enabled that. This could be another huge step forward in that direction. So I think the list is pretty long, but if you think about that list, it's very fundamental. 8-year-olds are doing these activities, and in a few years, they might be doing it dramatically differently. And that might require a huge update in our education system. But at the same time, I think in each of these areas, there are opportunities for significant harm that can come if the model's accuracy is not great, if it's imagining things that are not true, if we don't have good attribution, if fairness assessments are not done carefully, and then the world changes, and we need to keep an eye on that through monitoring and so on. So yeah, I mean, I think to summarize, what I would say is that there is potential here for some really, really transformative technology. It hasn't happened in a day, and it's not like it all came out of OpenAI and ChatGPT. It has built on a large body of work by a very significant community of machine learning researchers and practitioners. But we are at that cusp of something significant, and we just have to be careful about unleashing the force.
Yeah, I mean, I completely agree. And just I think a follow-up to that one would be, you mentioned about few things. I'll be curious. So for someone like you who has investigated the world of trustworthy AI, or it's deploying these AI tools in a very reliable manner in the world, I'm sure a lot of people are intrigued using ChatGPT in their own applications. Like there could be industries, there could be customer service places that can use ChatGPT to hold conversations. What would you say would be a starting point to make sure for these institutions to investigate how much reliable this ChatGPT is really if I deploy this current version? I'm sure a lot of better versions of ChatGPT are going to come through, but in the current state, like as of 2023 February, what do you think should be the thinking points or the starting points for anyone to get started or understand how much trustworthy ChatGPT is for my XYZ application?
Yeah, I mean, I think it goes back to a point that you made earlier, that having a framework for testing and validation and monitoring of these kinds of models is something that everyone should be thinking of if they're deploying these kinds of models in useful cases. And I think that kind of thinking has started from what I'm seeing. But that's kind of the key takeaway, if you will, that as you're building out these applications, leveraging large language models, from day one, think about testing and evaluation and monitoring of these kinds of models and maintaining their quality. That's good, both because it's the right thing to do, to be responsible as you are deploying powerful technology into the world, but it's also going to be good for business, because ultimately your business KPIs will turn on how effective these models are and are they making the right calls, which is what you get out of careful evaluation. Yeah, so I think that's the main takeaway.
Yeah. And one other specific question I had was, as in, like, because you have been working in this field, I'm sure you must have come across this tools such as Lime, SHAP, GradCam that help you build, like, back propagate these trained models and their representations to understand what the model is really looking at. I'm curious if you have a view on these. Like, are these enough when we work in this real world? Like, let's say if I have an imaging-based system, an AI system that is doing some predictions or segmentation, and if I use a GradCam to analyze what exactly the model is looking at in this image, does those, like, do those attributions, or basically class weights that we normally visualize in a heat map or saliency map way, are these enough, or do we still have like lots of limitations from these models and we have to still keep on innovating? I'm sure there are lots of GradCam++ and other solutions that try to improve, but even those narratives don't make a lot of sense when we actually work in real world applications.
Yeah, I think the tooling is valuable, but the way I think about this is a little bit from the starting point, a slightly different starting point, which is start from the top level attributes and metrics that you're trying to measure. So those could be metrics around performance, they could be metrics around drift or fairness and so on. And then that's what you're trying to, you have this kind of multi-metric view, if you will, of a model that says across all of these different attributes, how is the model doing? And if you have a set of models, you want to pick the best one, and sometimes making trade-offs because you may not have one that dominates on all of those metrics. Now, in order to get to that analysis level of detail, you have to do measurements first, and then you want to get into root cause analysis. And the methods and techniques have to be closely tied, if you will, to the higher level goals that you're trying to achieve. So some of the tools that you mentioned here are useful towards that end, but often like not one or two of these are sufficient to give you the full breadth of views as you go into deep learning models and large language models. You'll want to work with embeddings and things like that, which some of these are not necessarily that well suited for, weren't designed for. They were designed a bit more for the tabular data world, where you had a better view of interpretation of what individual features mean. Like in a fraud model, you might be looking at time of day of a transaction, or where it happened, was it online or in a physical store. Those features are interpretable by themselves. If you start looking at large language models in the embedding space, or you're looking at computer vision with pixels and higher level concepts, then there's a bit more to do to unpack the different building blocks, if you will. Giving interpretation to embeddings, for example, is non-trivial. It doesn't follow in any kind of obvious way from these kinds of tools. But that's kind of, if you think about this a framework for evaluation of models and monitoring and building confidence in them, then tracking metrics over time, understanding the root causes for why metrics are going up and down, being able to interpret the root causes in a meaningful way and focus in a meaningful way, that class of challenges is what takes us to the next level. These tools can be pieces of the puzzle, but there's a lot more that you need to do to actually enable all of this at scale.
Makes sense. Yeah. I definitely have a lot of more questions, but maybe I'll keep that for a separate conversation that we can dig into deeper. But before you sign off, I just have one last question, as in, like, what would you suggest would be the trends to look for in 2023? Because I think, at least for the AI world, I have seen like every maybe 1 year or within a less year, I think we have new technologies coming in. Like, I think after the transformer came, we have vision transformers that was changing the whole computer vision space. Then we had these GPT models, Dolly models. Now we also have something like a generative video model. I forgot the name for that, but that is like changing the scenery of a video just in one frame. So what would you say, based on your whole experience, how you have been tracking these fields? What are the biggest trends to look for in 2023, at least in AI space?
Yeah, I think, like, I do think that large language models is the area to keep an eye on. They are starting to get to that inflection point now where there is opportunity for just tremendous uptake and adoption. That's what I'm keeping my eye on for 2023.
I see. Okay. Yeah, I think we're just close to our finishing time. So I don't have any more questions for you now, but maybe I'll definitely want to have like a conversation separately that where we can dig deeper onto specific concepts of how these frameworks of trustworthy AI systems really look like. Maybe based on some use case examples that you have been through, and maybe I'll also link your TruEra, as in like the product insights, as in like people who want to check out what exactly TruEra does and what are the pricing solutions for that, they can check out. But apart from that, thanks a lot for being here. I think we talked a little bit nice about, I think, NLP topics, from how it started from foundation models all the way to what we have today, ChatGPT, which is like a very sophisticated tool, but it has been through a lot of versions of generative models. So thanks for the history. And also we talked a lot about trustworthy, which frankly to me, it has been very interesting because I work with a lot of medical institutions as a part of my PhD project. So it's like definitely like they are much more concerned about the non-accuracy values, like you said, the metrics or KPI that we typically develop for project. So I think it's very insightful what you shared, those understanding how to understand these metrics and devise such a valuation framework. So yeah, I hope everyone who was listening to this particular podcast also finds that useful, and maybe if they find it really interesting, they'll also reach out to you. So I'll also leave a link to how to contact you via LinkedIn or other platforms. But yeah, once again, thanks a lot for being here. It was really insightful.
Thank you, Jay. It was a pleasure.